Hello friends, I am Agrawal AS, Assistant Professor in Civil Engineering Department, Sandipani Technical Campus, Latur. Today's topic is calculation of maximum bend moment at a given section of 3-inch parabolic arch using ILD. Learning outcomes. After this watching the video, student will be able to understand the concept of ILD, and also student will be able to calculate the maximum bend moment in 3-inch parabolic arch using ILD. Now this is a numeric, a 3-inch parabolic arch of span of 40 meter and rise 8 meter. Find the maximum bending moment at a given section 10 meter from the left support when 200 kN load is moving from left to right. Now, suppose this is a 3-inch parabolic arch. And this span is a 40 meter and rise is 8 meter. Here is a hinge, here is hinge, and here is a hinge. Here the arch is subjected to a load of 200 kN load which is moving from a left to right. And we have to find the maximum bending moment at a distance of 10 meter from the left end. Suppose this point is a D, which is a 10 meter from the left support. Here is a support A, is the support B. Now here we have to use the ILD. For that, we have to draw the ILD for that. So we know the equation of bending moment at 10 meter, that is equal to a B moment minus H moment minus the H moment. So we have to draw the ILD for the B moment also and for the ILD for the H moment also, so that we get the bend moment at a section 10 meter from the left end. Now, so ILD for the B moment. Now if you want to the ILD for any purpose, that is maybe for any force, we have to apply the unit load on the section. Suppose like this is X and this is 1, and we have to find here the Z, and there Z is equal to the 10 meter. Support A, and this is the support B. So already we have seen the how to draw the ILD for the B moment in the previous lecture. So ILD for the B moment, that is like here. This is for the 10 meter. So this ILD is, and this ordinate is the Z by L into L minus the Z. So here in our case this Z is a 10 meter where we want the bending moment. This L is equal to the 40 meter, and this diagram is the positive. This is the ILD for the B moment. Now next is the ILD for the H moment. So next part is the ILD for H moment, or also we call it as the thrust moment or thrust moment. For that, this ILD is like this. That already we have seen the previous lecture. At the center, this is the L by 2 and here is the L by 2, and here at the center this height is the same as that of the B moment. So this is nothing but the L by 4H into the YD. This YD is here. This YD is nothing but this is our YD. So if you put here the YD, so this equation becomes the or L by 4H into the, we know for this YD the equation is 4H into the Z divided by L square into the L minus the Z, because here is a, in this case our X is equal to the Z. X is equal to the Z. So this 1L gets cancelled out, this 1L gets cancelled out, this 4H gets cancelled out. So this remaining is the Z by L into the L minus Z. Now here this height is L Z by L into L minus Z, and this diagram is negative because here we know that this H bending moment is create the hogging bending moment. That is why it's a minus. So this diagram is minus. So here we have to superimpose both this diagram, that is the B moment and the H moment. So here we draw the separate diagram for the B moment and the H moment. Before that, okay. This is the Z by L into the L minus Z. The distance is 10 meter. This is the B moment. Then we draw here the H moment. This is the height. Now this diagram is a plus. This B moment is a plus and this H moment is the minus. Now this also the height is Z by L into the L minus Z. So both the height is the same. Both height is the same. So we find here the height Z is a 10, L is equal to the 40 into 40 minus the 10. So that becomes here 10 into 30 divided by the 40. So that becomes the 7.5. So this height is 7.5 and so this height is 7.5. Now here, so we have to find out the maximum of positive bending moment and maximum negative bending moment. So for maximum positive bending moment, suppose we want here how this, we can write here this load into the ordinate. Load into the ordinate. Which ordinate now? This ordinate. This ordinate. Because this, the common part gets the cancel out. This common part gets the cancel out. So here the remaining is what? This is the positive area. This is the positive area and this is the negative area. So this height, load into this height, suppose this is the y1. So we can say that here that is equal to 200 into the y1. So that is the maximum bending moment, positive. How to find this now, the y1? How to find this y1? We know this is a 75. Suppose this is the y2. Suppose this height is the y2. So we have to, total height is 7.5. So 7.5 minus this y2. How to find this y2? So that here we can say that suppose this height is the y3 and this remaining height is the y4. So how to find this y3? Suppose this total is the, we know that it's 75. So by using this use of the rule of the symmetric triangle, this total height 75 and this distance is the 20 meter, because this is at the center. This is at the center. So by symmetry of triangle, this 77.5 divided by this the 20 is equal to y2 divided by this 10. The triangle is like this. Suppose this triangle. If you draw this separately, we can see that here is like this. This height is the 7. This height is the 7.5. This is the y2. This is 10 meter, and this is the 20 meter. So by symmetry of triangle, we can say that here this 7.5, this 7.5 divided by this 20 is equal to this y2 divided by the 10. So here we got the y2 is equal to 3.75. So how much is y1? So we can say that here y1 is equal to, total height is the 7.5. This height is a 7.5. This minus the y2. So 7.5 minus 3.75. So remaining is the 3.75. So we can say that here maximum positive bending moment is equal to, load is the 200 and this y1 is the 3.75. So that is equal to 750 kilonewton meter. So in this way we got the maximum positive bending moment. Now the next part is the maximum negative bending moment at the 10 meter. So that again is equal to the B moment minus H moment. The same diagram that we have to use here. So that is equal to this load into the ordinate. This ordinate is what? This should be the maximum. This ordinate should be the maximum as in the case of the previous. So here this is our diagram. Now here is a maximum ordinate at this location. At this location is the maximum ordinate. this. So load into this ordinate. We have to keep the load on here. 200 kilonewton. In the previous case also the same, that is we have to put the load at here 200 kilonewton. So that will get this load into this maximum positive ordinate will get the maximum positive bending moment. So in the case of negative, this load into the maximum negative ordinate. That is how much is the Y3. So we can say that here that is equal to 200 into the Y3. Now we have to calculate the Y3. For that we have to calculate the Y3. How much that? Total height is the 7.5 minus the Y4. Now how to calculate the Y4? By symmetry of this triangle. Symmetry of this triangle. So we draw here the symmetry of triangle below. This height is the, now this is 7.5 and this distance is the 10 meter. Then here is another triangle that we know. And we want this is Y3 and this is the Y4. We know this distance is the, how much is 20 meter because it is at the center. This is the 20 meter. So by symmetry of triangle, this height divided by this distance. So this is the total is the 40. This total is the 40. So this 40 minus 10. So that is the 30. So we can say that here 7.5 divided by 30 is equal to this Y4 divided by this distance. How much is it? 20 meter. It is 20 meter. So we got here this Y4 is equal to 5. 7.5 divided by 30 into 20. So that is the 5. This ordinate is the 5. So we want the Y3. How to find this Y3? Or how to find this Y3? Here is Y3. So Y3 is equal to, this is equal to, this total height is the 7.5 minus the Y4. So we can say it here. Y3 is equal to 7.5 minus the 5, that is the 2.5. So maximum negative bending moment is equal to, load is the 200 and maximum order is the 2.5, and this is the negative bending moment. So we can say that this is the minus 500 kilonewton meter. So this is the maximum negative bending moment at a section 10 meter, at a section at 10 meter. The previous one is the positive bending moment is the this 750 kilonewton meter at section at 10 meter. Thank you.